Good afternoon, sir.
Good afternoon.
Sandesh, sir, we can start by 3-5.
Yes, miss.
Yeah.
Rushali ma'am, can we start?
Yes, madam. We can start.
Okay. Sir, with your kind permission, can we start?
Yes, ma'am.
Okay. Rushali ma'am, please.
Yes, yes. I request everyone to please raise for national anthem.
गण मन अधिनायक जय हे भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्छल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगल दायक जय हे भारत भाग्य विधाता जय हे जय
everyone.
So, Savita ma'am, start.
Yes, sir, Sandesh, sir.
Hello, good afternoon, one and all present here. This is Assistant Professor Sandesh Tambe. Welcomes you all on the behalf of Bharat Friend Association, Bharat College of Arts and Commerce, to this ICSSR sponsored 10 days national level training and capacity building program on research methodology. Today is the 7th day, and today we have with us a very eminent personality, Dr. Atman Shah. In yesterday's session, Sir told us about the parametric space and how the SPSS work. Today also we are continuing with the same session, that is hands-on training with using the SPSS. So without wasting much time, I request Atman sir kindly take a charge and start today's session. Atman sir, over to you.
Thank you. Thank you so much, sir. So, like I said, we discussed some of the basic parametric tests yesterday. One sample t-test, independent t-test, and paired samples t-test. So if you have any doubts regarding the t-test, you can ask now, so we can solve the doubts and then start working on ANOVA, analysis of variance, one-way ANOVA, two-way ANOVA, and post hoc analysis. So if you have any doubts related to theory and SPSS, you can write in the chat box, or you can also unmute yourself.
Sarita ma'am, I request you to get it out cleared. I have transferred your question to sir, so you can unmute yourself and talk.
Yeah, good afternoon to all. Actually, yesterday when I tried doing that hands-on training, and in that the trial version shows like this. I'm sharing my screen now. Is it, ma'am, can you allow me to share my screen?
Yes, Rushali ma'am, please allow the participants to share their screen.
Yes, yes, she can share. Just a minute. Sarita madam, please share.
Yeah. So when I click on that analyze, this box comes in. So what to do with this? Is it visible?
Can you please close this?
Yeah.
Okay, now go to analyze.
Sorry.
No, not this. This is go to tab, go to analyze.
Yeah, actually that there is a, I'm not able to see that because of the.
It is just next to the transform. Analyze tab. See file, edit, view, data, transform, and analyze. Next to transform is analyze.
Yeah, just a minute. Sir. Because of this. I'm not able to go there because this tab is hidden behind the next tab. Yeah.
No, not power analysis. Go to compare means.
Okay.
Yes, here you have the option of one sample t-test, independent samples t-test, and paired samples t-test.
Okay.
Right?
Fine, sir. Thank you. Thank you so much.
Okay. Okay, any other questions? Anyone?
Please, if you have any doubt, you can unmute yourself and you can ask your doubts.
Okay, so let's understand the idea of analysis of variance. Another parametric test, important parametric test, as we discussed yesterday, t-test is used when paired t-test is used when you have two paired groups, and independent t-test is used when you have two unpaired groups or two unrelated groups. But we do have more than two groups, right? And therefore we need another statistical test to deal with more than two groups. So analysis of variance is one of them. So in the first step, we are going to discuss the idea of one-way ANOVA and two-way ANOVA, or why ANOVA is required, hypothesis formulation, and SPSS procedure and interpretation of the data, interpretation of the result. Now, why ANOVA? Independent samples t-test is used when we have only two independent groups. For example, male and female, Hindu and non-Hindu, lower and upper income group. But we do have more than two groups or more than two categories in our nominal variable. We have seen that in income, we do have lower, middle, and upper income group. So in that case, we have three categories. Then how to analyze these three independent groups? Now we are talking about only independent groups. Two or more independent groups and not paired groups. For example, Hindu, Muslim, Christian, and Jain, lower, middle, and upper income groups. So the first question is, why can't we use several independent t-tests for various pairs? Let's take the example of religion. Suppose we have this nominal variable. So nominal variable is religion. In religion, we have four categories. So we can assign 1 to Hindu, 2 to Muslim, 3 to Christian, and 4 to Jain. So religion is our nominal variable because order doesn't matter. You can assign any numbers. You can assign 1 to Muslim, 2 to Hindu, 3 to Christian, 4 to Jain. Right? Then why can't we use various pairs? Various independent samples t-test for various pairs. So for example, first independent t-test for Hindu and Muslim. Then second, Hindu and Christian. Third, Hindu and Jain. Fourth, Muslim and Christian. Fifth, t-test Muslim and Jain. And sixth, t-test Christian and Jain. So we need to perform 6 independent samples t-test in this case. Right? Now, what's the problem in performing various independent samples t-test for various pairs? Using t-ratios for each pair would be time and energy consuming. It is obvious because you need to perform t-test 6 times. Right? But more statistical problem, the technical problem is it increases the probability of type 1 error, probability of rejecting true null hypothesis when H0 is true. Right? Let me try to explain this. Suppose you are performing t-test for Hindu and Muslim pair. So when you perform t-test, your alpha is 0.05. So there are 5% chances that you are rejecting true H naught. Then you are performing another t-test for another pair. So every time you perform the t-test, you are committing 5% error. So it increases the probability of type 1 error. Right? And therefore, we are not performing various t-tests or more than one independent samples t-test for various pairs. For different 6 t-ratios, we obtain significant difference in only 2 t-ratios. For example, you find significant difference in Hindu and Muslim and Jain, but not for other 4 pairs. Now, can we conclude that we have the significant difference in the entire population? It is quite difficult. Because in 4 pairs, your t-ratio, your t-statistic is not statistically significant. But in 2 pairs, your t-test is statistically significant. So it is quite complicated, quite difficult to conclude for the entire population. And therefore, we are not using more independent sample t-test for various pairs. To overcome this problem, another single statistical test is required. What we require? We need single statistical test which holds alpha constant at 0.05%. That means we are not increasing the type 1 error. If you perform 6 independent samples t-test, in each and every t-test, your alpha is 0.05. So in each and every t-test, you are committing 5% error. You are allowing 5% error. Right? But here, we need single statistical test holding alpha constant at 0.05. Now, what are the assumptions? Sample should be collected randomly. The selection of observation should be independent. We have already discussed these 2 assumptions. The variance of the population should be unknown. Data must be continuous, interval or ratio. Data must be, population should be normally distributed, and therefore it's a parametric test. This is very important. Variances of all independent groups are equal. Right? We did this analysis in the independent samples t-test, the Leven's test for equality of variances. So here also we assume that variances of these 2 groups or 2 or more groups are equal. So under these assumptions, we can perform either one-way ANOVA or 2-way ANOVA. So these 2 assumptions make ANOVA a parametric test. Right? Okay, now let's understand the idea of one-way ANOVA. What do we mean by one-way ANOVA? So one-way ANOVA is a statistical tool to compare the means of 2 or more than 2 independent groups. So it is the extension of independent t-test. So one-way ANOVA is used when we have 2 independent groups also. But we have independent samples t-test exclusively for 2 groups, and therefore we always use one-way ANOVA when we have more than 2 independent groups. So if you use one-way ANOVA for 2 groups, your answer of one-way ANOVA and independent samples t-test would be identical. So one-way ANOVA is used when we have more than 2 groups. However, you can use one-way ANOVA, or it is not wrong to use one-way ANOVA when you have 2 groups. In other words, it's a statistical tool that is used to check if the means of 2 or more groups are significantly different from each other. So in ANOVA, we are comparing means only. The name is analysis of variance, but we compare means. Right? So in independent sample t-test, we compare mean of two independent groups. Here we compare the mean of more than two independent groups. Now, this is very important. Now, if you find ANOVA result statistically significant, so from that analysis, you cannot identify that which group is different from others. Right? So in our sample, we have the data on faculty. In faculty, we have 4 categories: arts, commerce, science, and management. Suppose you find significant difference in external marks. Now, which group is different? Arts is different from commerce, science, and management. Management is different from other 3 groups. All 4 groups are different. Arts and commerce are same. They are different from science and management. That we cannot identify. We are only saying that yes, we have the significant difference. But suppose you want to identify that group or groups, you need to perform post hoc test. You need to perform post hoc test. So ANOVA test is omnibus test. So this is the idea of one-way ANOVA. Again, when you have 2 independent groups, use independent samples t-test. If you have more than 2 independent groups, use one-way ANOVA. Right? You need to have the quantitative data, and that quantitative data must be normally distributed to perform one-way ANOVA. And if you have a significant result, then you need to perform the post hoc test to identify the group. If your F ratio is statistically insignificant, that means you don't have any difference, then there is no reason to perform post hoc test. Right? Let's understand one-way ANOVA with the help of examples. Examine the significant difference in the annual salary of arts, science, commerce, and management graduates. So here annual salary is our dependent variable. And it must be normally distributed, normal distribution. Right, and then we have 4 groups: arts, science, commerce, and management graduates. So you randomly collect the data from these 4 groups. You collect the data of arts graduates, science graduates, commerce graduates, and management graduates randomly. And then check whether you have a significant difference or not. Second, to examine the depression level of students from various fields, such as medical, engineering, management, and commerce students. So here depression level is dependent variable. And it must be normal distribution. Normally distributed. Then we have 4 groups: medical, engineering, management, and commerce. Right? D. Examine the effect of 3 different pedagogies on the overall result of the students. So result is our dependent variable. It must be normally distributed, and we have 3 different pedagogies. So teaching method 1, method 2, method 3. Fourth, to examine the different hormone treatments on the level of depression. So again, level of depression is our dependent variable, and we have different hormone treatments. So you can have 3, 4, 5, 6 hormone treatments and check the significant difference at which hormone treatment is more effective in dealing with depression issue. To examine the educational attainments of students belong to different caste and religion. So educational attainments is our dependent variable. Right? And different caste and religion. So we have more than 2 groups here. You can take open category, EWS, OBC, SC, ST, or in religion, Hindu, Christian, Muslim, Parsi, and check whether you have any statistical significant difference or not. So in all cases, we have more than 2 independent groups. Right? Our groups are mutually exclusive. What we are saying, our groups are mutually exclusive. Right? How to frame hypothesis, null and alternative hypothesis in case of one-way ANOVA. First, that is null hypothesis. No significant difference between means of k independent groups. So for example, we have k independent groups. So mu1 is equal to mu2 is equal to up to mu k. Right? So mean of all independent groups are same. Alternative hypothesis, mean of at least one independent group is significantly different from others. So instead of this, you can also write like this. Mu1 is not equal to mu2 is equal to mu3 to equal to mu k. Right? So at least one group is different. If one group is not different, then you don't have any significant difference. So in alternative hypothesis, we are seeing that at least one group is different. So 2 groups can be different, 4 groups group can be different, but at least one group is different from others. Now, which group is different? That we can identify with the help of post hoc test. ANOVA result will not help you to identify the group which is different from others if you reject null hypothesis. So make sure you perform post hoc test if you reject null hypothesis. Perform post hoc if H0 is rejected. Right? So first, random selection of sample. We collect the data randomly. Second, check the normality assumption. You need to check whether data is normally distributed or not. We have already discussed this, how to check the normality assumption with the help of explore command. Define null and alternative hypothesis, specify the level of significance, perform the test. This is the decision rule. If p-value is less than alpha, reject the null hypothesis. If p-value is greater than alpha, we fail to reject the null hypothesis. Then perform post hoc analysis if F ratio is significant or when H0 is rejected. Right? If F0 is not rejected, that means you don't have any significant difference. So all groups are equal. And therefore, there is no reason to find or to perform post hoc analysis. Let me share my SPSS screen. Yes, any doubt in one way ANOVA in theory? Anyone? Okay. So here we have the data on stay and internal marks. Sir, kindly share. Yes, I'll share all my PPTs. Don't worry. So suppose we are interested to know whether we have a significant stay-wise significant difference in internal marks. What we want to check? Stay-wise significant difference in internal marks. So in stay variable, we have three categories: home, hostel, and PG. Right? Internal marks follow the normal distribution, so therefore we can use one-way ANOVA. Since we have more than two groups and we are interested to compare the mean of these three groups, we can perform one-way ANOVA. Right? Now, what is the null hypothesis in this case? So H naught no significant difference let's write no stay-wise significant difference in internal marks, right? And alternative hypothesis we have, there is a significant difference in there is a stay-wise significant difference. Or in H naught you can also write internal marks of home, PG, and hostel students are same. Right, and here you can write internal marks are of home, PG, and hostel students are not same. Or at least one group is different from others. So this is how we frame null and alternative hypothesis for one-way ANOVA. Okay, let's perform it. So go to analyze. In analyze, go to compare means, and in compare means we have the option of one-way ANOVA. Again, go to analyze. In analyze, we have the option of compare means. In compare means, go to one-way ANOVA. As I said, we are comparing means, and therefore one-way ANOVA option is available in compare means tab only. So click on one-way ANOVA. Now, what is our dependent variable? It is internal marks. So select internal marks and move it to the dependent list box. What is our independent variable or factor? It is stay. So select stay and move it to the factor box. Right? Now go to options. Select descriptive statistics. and means plot. Descriptive and means plot. Continue, click OK. It will take some time. Yes, now we have the result. So first we have descriptive table. So here we have sample size n. So 19 hostel students, 22 PG students, and 19 home students. Then we have mean 18, 17, 17, 17. Right? We also have minimum and maximum values. Now this is our ANOVA result. Now those of you who have performed one-way ANOVA manually can easily identify this table. This is sum of squares, SS. This is mean square, MSS. Right? This is our F ratio, that is MSS upon sum of squares. 0.057. And associated SIG value is 0.945. Now this SIG value is higher than 0.05. Now since this SIG value is higher than 0.05, we fail to reject H0. And if we fail to reject the H0, we conclude that there is no significant difference. There is no stay-wise significant difference. So there is no significant difference between hostel, PG, and home students in terms of internal marks. So internal marks of hostel, PG, and home students are same. And you can see the mean, there is no significant difference. Right? See here, this column in descriptives. The mean marks of hostel students is 18.05, PG students 17.5, home students 17.89, and overall mean is 17.80. See mean plots. Hostel, if you see, it is 18.05. If you double click on it, you can edit it. Sorry. Close it. You can see the value. Now, since we don't have any difference here, there is no difference. So all groups are equal, and therefore there is no need to perform post hoc test. Right? Okay. So let me change the data and let's see what happens. Now, intentionally, I'm giving more marks to home students between 25 and 30. So give marks in the range of 25 to 30 to home students. Okay, so now we have the data in which the whom students have internal marks between 25 and 30. Let's perform one-way ANOVA again. And see the result. This is descriptive statistics. So you see the change in the mean marks of home students. It is 27.53 here. Right? Then you see ANOVA table. Let me. This is ANOVA result. F ratio is 27.467 and SIG value is less than 0.05. And therefore we reject H0. Since we reject H0, we are saying that we have the significant difference in internal marks. We have significant difference in internal marks. And then you see this mean plot. This is home students. And you can visualize the difference. Right? Now we are interested to know that which group is different. Arts is different from commerce and science. Commerce and science is different from hostel is different from home and PG. PG is different from home and hostel. But to identify this group, we need to perform post hoc analysis. So let's see how to perform it. Go to the one-way ANOVA tab again. In one-way ANOVA, here we have the option of post hoc. See this post hoc tab. We have various statistical tests to perform post hoc. So I'm going to use Turkey, and in two-way ANOVA, I'm going to use Shah. Both generate same result. So select Turkey. Significance level is 0.05. Continue. Okay. Now what post hoc analysis does? Post hoc analysis compares the one group with remaining groups. Let me copy paste this in Word file. So it will be easier to visualize the difference. This is the multiple comparison table. Now see what multiple comparison table does. Here we have one category, hostel. Now we are comparing the mean of this hostel category with the remaining categories. Right? Now you see the difference, mean difference. It is 0.553. See this SPSS output file. Mean difference. Now we are comparing this. Home with hostel with PG and home. PG with hostel and home with PG and hostel. Right? So you see the difference hostel and PG. See here, hostel is 18.05, PG 17.50. So what is the difference? 0.553. Whether this difference is statistically significant, see this. No, because it is higher than 0.05. So hostel, the mean difference between hostel and PG is not statistically significant. And therefore, the internal marks between hostel and PG group is not significantly different. Right? Then compare hostel and home. This is mean difference minus 9.474. Associated p-value is this. So it is statistically significant, and see star is here. That star means the mean difference is statistically significant at 0.05. So hostel and home are different. So let me highlight this by using red color. Now we have this second comparison. Comparison of PG with remaining categories. So PG and hostel, it is exactly same as hostel and PG. So there is no difference. You see the value here, we have 0.553 and here we have minus 0.553. So it is not statistically significant, but PG and home, the mean difference is minus 10.026 and associated p-value is 0.000, and therefore we have the significant difference. So PG and home are also different. And then we have home category. Home and hostel. So it is opposite to hostel and home. We have the significant difference. Home and PG, which is opposite of PG and home. Again, we have significant difference. See here, in both cases, p-value is less than 0.05. So mean difference are significant. So from this table, we can identify 2-3 things. First, home and PG, see hostel and PG are same, no significant difference. Or we can write mean difference is not significant, right? PG and home, mean difference is significant. See this second category. And then third, home and hostel, mean difference is significant. So overall, we can say home is different from PG and hostel. Right? Home is different from PG and hostel. Let's see homogeneous table here. This table. You see, we have two groups, group 1 and group 2. So group 1 contains PG and hostel, which are same. Home group is different. So that is what we have written here. Home is different from PG and hostel. So since the marks of home students are statistically significantly different from PG and hostel, we have the overall significant difference here. Right? Let's see what happens if all three groups are different. Go to SPSS file again and give marks in the range of 5 to 10 hostel students. Between 5 to 10. Right? And let's perform one way ANOVA again. See result here. We have the overall significant difference. So let's check whether yes. See SIG value. All SIG values are statistically significant in this comparison table. Right? And therefore, here we have three groups. See these homogeneous subsets table. Group 1, hostel, group 2, G, and group 3, O. Right? Yes, any doubts? One way ANOVA. Anyone? Let me please see row 3. Could you please tell me in which table? Ravi Chandra. That was old while changing the values. Okay. But we have the output of old values, so you can still see it if you wish to, if you wish me to share. Okay, thank you. Yes, any other doubts? So do one thing. We have the data on external marks. You have 5 minutes. Let's try to find out whether you have any significant difference, stay-wise significant difference in external marks or not. So here we have the data on external marks and then stay-wise difference. Instead of internal marks in variable column, dependent variable column, you need to write external marks. and try to find out whether you have the significant difference or not. And write your answer in the chat box. Your p-value, F ratio, p-value, and whether you reject the null hypothesis or not. Okay, so SIG value is 0. F value is 0.883, SIG value is 0.419, and we fail to reject the null hypothesis. Right. So suppose we have 4 categories in faculty. So let's see. Instead of stay, I am using faculty for internal marks. So here we have mean marks. This is F ratio. Since this SIG value is less than 0.05, we reject H0. So if we reject H0, we have the significant difference. Now, which group is different? See post hoc analysis. First, compare these arts with commerce, science, and management. So arts and commerce, no significant difference. Arts and science, no significant difference. Arts and management, no significant difference. That means arts is not different from commerce, science, and management. Okay. See commerce and arts, no difference. Commerce and science, no difference. Commerce and management, no difference. Then comparison of science with other groups. So science and arts, no difference. Science and commerce, no difference. Science and management, we have the difference because p-value is less than 0.05. That means mean internal marks of science and management students are significantly different from each other. Okay, comparison of management with the remaining groups. So management and arts 0.271, no significant difference. Management and commerce, no significant difference. Management and science, we have the significant difference. right? So that means management and science group are different from each other. Now see homogeneous subset table. We have two groups. Now these commerce and science groups can make a group with science also. Sorry, commerce and arts can make a group with science also and with management also. So if we have group 1, then group 1 consists of science, commerce and arts, and group 2 is management. Group 1, science, commerce and arts, and group 2, management. This is one possibility. Second, science is different. So group 1 consists of science, and group 2 we have commerce, arts and management here. Right, so arts and commerce can go with science also and management also. See main plots. So here we have management students marks. Double click on it. Labels. Close it. So you can see the marks of management students are significantly different, right? And that is what we have seen in the multiple comparisons table. Science and management, we have significant difference. Science and management. Right? Okay, so let's try to perform one-way ANOVA on external marks and total, both faculty wise. Whether you have faculty wise difference in the external marks and total marks of the students. So write your F value and SIG value in the chat box. You have 5 minutes. Did anyone perform? Any answer? For external marks and total? Okay, let me perform. Instead of internal marks, select external marks and total both simultaneously. Click on OK. So here we have the descriptive statistics and then we have ANOVA. So you can see in both cases, SIG value are statistically insignificant. That means we don't have significant result. So we fail to reject H0 for both cases. Right? Since we fail to reject the null hypothesis or F ratios are statistically insignificant, there is no reason to perform. But still you perform, see what happens. See result for external marks. All SIG value are statistically insignificant. That means mean difference between various categories are statistically insignificant because we don't have any difference. See for total marks also. All values are statistically insignificant. And therefore, if you look at the homogeneous table, you have only one group. For external marks and also for total marks. Because we don't have any significant difference. And this is the mean plots for total and external marks. Right? Yes, any questions related to one-way ANOVA or multiple comparison table or homogeneous table? Anyone? Have you performed this test? One-way ANOVA test on total marks and external marks? Okay. Let's start to understand the idea of two-way ANOVA. So what is two-way ANOVA and how it is different from one-way ANOVA? Two-way ANOVA is used when we have two independent variables and one measurement variable. We have two independent variables and one measurement variable. These two independent variables are measured on the categorical scale. So they are nominal variables. These two independent variables are nominal, and they are also known as factors. So in other words, there are two factors in two-way ANOVA, and each factor has several labels or categories. So we have two nominal variables, and each variable can have various categories. 2 categories, 3 categories, or 4 categories, right? And one measurement variable which is continuous, and it must be normally distributed. So measurement variable is our dependent variable which is continuous, and it must be normally distributed. And we have two nominal variables, sorry, two independent variables which are measured on nominal scale, and they can have more than two or more categories. Now, two-way ANOVA shows two effects. First is a separate effect. Now, separate effect indicates the effect of each individual independent variable on measurement variable. Now, suppose we have two independent variable x1 and x2, and our dependent variable is suppose y. These two are independent variables, and this is our dependent variable. This independent variable x1 can have various categories, x2 can have various categories. So what is separate effect? Separate effect indicates the effect of x1 and x2 on y separately, individual. So effect of x1 on y and effect of x2 on y, that is separate effect. And second is interaction effect. Now, interaction effect generates or shows the effect of two independent variables simultaneously on the measurement variable. So simultaneous effect of x1 and x2 on y. That is the idea of interaction effect. So separate effect is the individual effect of each independent variable on dependent variable, and interaction effect helps us to understand the simultaneous effect of two independent variables on our dependent variable. So that is the idea of two-way ANOVA. Let's understand it with the help of examples. First, examine whether we have significant difference in the annual salary of various types of occupation and gender. Now you see, annual salary is our dependent variable. And it must be normally distributed. Right? Various types of occupation. So this is our first independent variable, and gender our second independent variable. And these two independent variables have various categories. So in types of occupation, we have agriculture, non-agriculture, manufacturing, services, gender, male and female. Right? So separate effects examines the effect of types of occupation and gender on annual salary individually, separately. An interaction effect helps us to understand the effect of types of occupation and gender simultaneously on annual salary. That is the idea of interaction effect. Second, analyze the effect of various fertilizers and planting density on crop production during the harvest time. So crop production is our dependent variable. It must be normally distributed. Fertilizers and planting density are two independent variables. So in fertilizers, we have various categories. organic fertilizer, inorganic fertilizer. In planting density also you can have various categories. And then we are interested to know the separate and simultaneous effect of these two independent variables on crop production. Third, examine the significant difference in the average years of schooling of girl child for mothers belong to various religion and their education level. So average years of schooling is our dependent variable. It must be normally distributed. Then we have two different independent variables, various religion and their education level. So religion can have various categories, education level can also have various categories. Primary school, secondary school, higher secondary, higher education, right? And then we are interested to know the separate and simultaneous effect of these two variables, of these two independent variables on dependent variable. Fourth, analyze the effect of sports activities and artwork on mental development of school children. So mental development is our nominal variable. We can have a score which must be normally distributed. And then we have sports activities and artwork. So whether your children are involved in sports activities or not, they're intensively involved, they're moderately involved, they are slightly involved, there is no involvement at all. Similarly in artwork. So we are interested to know the simultaneous and individual effect of these two independent variables on our dependent variable. How to formulate null and alternative hypothesis. This is very important in two-way ANOVA. So we have three sets of null hypothesis. Two sets of null and alternative hypothesis for individual effect and one for interaction effect. So first null hypothesis is there is no significant effect of first independent variable on measurement variable. An alternative hypothesis, a significant effect of first independent variable on measurement variable. Right? Second set, no significant effect of second independent variable on measurement variable. An alternative hypothesis says that we have the effect of second independent variable on measurement variable. So these two are for separate effect. Or individual effect. So when we analyze the effect of first independent variable, we assume that there is no effect of second variable on our dependent variable. And when we analyze second independent variable, we assume that there is no effect of first independent variable on our measurement variable. Third, this is for interaction effect. So no simultaneous effect of two independent variables on measurement variable. And again, we have the simultaneous effect of two independent variables on measurement variable. So this is how we formulate null and alternative hypothesis in one-way ANOVA. So in our example, suppose you take this example, annual salary, types of occupation and gender. All right. So what is your first null hypothesis, first set of hypothesis? There is no effect of types of occupation on annual salary. So first we write that H01. No significant effect of types of occupation on annual salary. And first alternative hypothesis, we have the significant difference in types of occupation on annual salary. Second set, H02, no significant effect of gender on annual salary. And second alternative hypothesis, we have the significant difference or significant effect of gender on annual salary. And then third, for interaction effect, there is no simultaneous effect of types of occupation and gender on annual salary. And third alternative hypothesis, we have the simultaneous effect of gender and types of occupation on annual salary. So this is how we frame null and alternative hypothesis for two-way ANOVA. So we are examining these three sets of hypotheses when we perform two-way ANOVA. So first, random selection. Second, check the normality assumption. Define null and alternative hypothesis. Specify level of significance. Perform the test. This is the decision rule. Reject null hypothesis if p-value is less than alpha. Fail to reject when p-value is greater than alpha. And if your F ratio is statistically significant. So if you reject null, reject H0, then you need to perform the post hoc analysis. Otherwise, there is no need to perform the post hoc analysis. Right? Yes. Any doubts? Anyone? In two-way ANOVA? Let me check the chat box. Okay, so I think there is no doubt. So let's take 5-10 minutes break and we'll explain how to perform two-way ANOVA in SPSS and how to interpret its result.
Okay.
Yes, sir. Sir, we'll have break for 10 minutes and then we can rejoin. The meeting will be on. Participants are requested not to leave. Sir will be joining and we'll be starting again.
Please fill the feedback form for session 1. Then we'll have break of 10 minutes.
Shall we start, ma'am?
Yes, sir.
Okay.
Yes.
Let me share my screen. Okay, so let's try to perform two-way ANOVA. So here we have these two independent variables, gender and stay, right? And we are interested to know whether we have the gender-wise, stay-wise effect on internal marks. So first independent variable is gender. Second independent variable is stay. And in gender, we have three categories. In gender, we have two categories. In stay, we have three categories. Then we have internal marks. So what is null hypothesis in this case? The null hypothesis says that there is no gender-wise effect or gender or internal marks of male and female students are not significantly different. An alternative hypothesis says that we have the significant difference. That is the first set of hypotheses. Second set. There is no stay-wise difference. So there is no effect of stay on internal marks. An alternative hypothesis says that we have the effect of stay on internal marks. And third set of hypothesis shows the simultaneous effect. So do we have simultaneous effect of gender and stay on internal marks? That is the idea, right? So go to analyze. Analyze general linear model and univariate. Again, analyze general linear model, univariate. So click on univariate. Now what is our dependent variable here? Our dependent variable is internal marks. So select internal marks and move it to the dependent variable box. Our fixed factors are two independent variables. So first is gender, second is stay. Select these two and move them to fixed factors box. Right? And simply click on OK. See this result. So here we have this sample size. We have 30 male students, 30 female students, 19 hostel students, 22 PG students, and 19 home students. This is the result of two-way ANOVA. Two-way ANOVA. So first, check the gender row, whether we have any significant difference gender-wise. See the associated F ratio, it is 1.188. Associated SIG value is 0.280. So for gender, variable, H0 is not rejected. because SIG value is higher than alpha, P is higher than alpha. Let's check stay variable here. Associated F ratio is 125.049. The associated SIG value is 0.000. Now for for stay, H0 is rejected. Why H0 is rejected? Because P value is less than alpha. Since P value is less than alpha, we reject the null hypothesis, and therefore we have the separate effect of stay on internal marks. These two are for separate effects. Separate effects. Now see this gender cross stay, this column, this row. That shows the interaction effect. So the F ratio is 2.330 and associated P value is 0.107. So P value is greater than alpha, and therefore we reject H0. So there is no simultaneous effect of gender and stay on internal marks. Right? So no separate effect of gender on internal marks. We have the separate effect of stay on internal marks, and there is no interaction effect between gender and stay. Now we are interested to know that which group is different in stay, because ANOVA will not help us to identify the group. So go to two-way ANOVA tab again. See, here you have the option of post hoc. So for which variable you want to perform the post hoc test? So we want to perform the post hoc test for stay. Now there is no reason to find the post hoc test when you have only two categories. Suppose you find the significant difference for gender. Right? Suppose you are finding significant difference for gender. But in gender, you have only two categories. When you have only two categories, we can easily identify that male is different from female. There is no reason to perform post hoc test. So perform post hoc test when you have the significant difference and when your nominal variable has more than two categories, the way we have in stay. In stay variable, we have three categories: home, hostel, and PG. Right? And we have the significant difference. So move stay to post hoc test for and then select Shah. So as I said, Turkey and Shah both generate the same result. So simply click on continue. Go to plots. Let's create plot gender cross stay. Add them. Select gender. Let me do it again. Select gender in horizontal axis and stay on separate lines. And then click on add. So this gender cross stay. Continue. Okay. See this result of multiple comparisons table. SIG values. Now all SIG values are statistically significant. All values are less than 0.5. Right? Now all SIG values are less than 0.05. That means we have the significant difference between hostel and PG. First, hostel and PG. Second, home and PG. Right? So here if you see the subset, all three groups are different. Group 1, group 2, group 3, sorry. Group 1, group 2 and group 3. Right? So this is how we perform two-way ANOVA. Now let's perform two-way ANOVA for external marks. So try to perform two-way ANOVA for external marks and total marks. And write your F value and P value in chat box. You have 5 minutes. Any answers? Okay, let me perform. Go to analyze, or you can directly go to the two-way ANOVA box. Instead of internal marks, select external marks, click on OK. So here you can see you don't have any significant difference, separate effect or interaction effect. Gender, stay, and interaction effect. All p-values are statistically insignificant. Right? So we fail to reject H0. Since we fail to reject H0, there is no need to perform post-hoc test. Still you perform, you see all significant values are, or p-values are statistically insignificant. That means there is no significant difference between hostel and PG, PG and home. See mean plot. So double click on it. Click labels. Right, so 1 is assigned to hostel, that is why 1 is written, 2 is assigned to PG, and 3 is assigned to home. And then you have mean marks. Perform to ANOVA for total marks. Instead of external marks, you can put total. Click on OK. So again, you don't have any difference. All statistical values are insignificant. All these three values, they are higher 0.0, 0.05. Right, and then we fail to check H0. So this is the idea of two-way ANOVA. Yes, any doubts in one-way and two-way ANOVA? If you don't have any doubts, we can try to understand the idea of correlation analysis and regression analysis. Anyone, any doubts? Yes, Savita ma'am.
Yes, sir, correlation.
Yeah, okay. Let me open the PPT. Okay. Okay. So let's try to understand the idea of correlation analysis, right? So what is the meaning of correlation analysis? Difference between correlation and causation, interpretation of correlation coefficient, hypothesis formulation, and some useful coefficients. There are various methods to find the association between two or more variables. Correlation is a statistical tool to find the strength of the association between two or more variables. For example, price and quantity demanded, income and expenditure, rain and crop production, gender and salary, occupation and salary, caste and education, right? So here you can see some variables are quantitative, some variables are qualitative. Gender is a qualitative variable, occupation is a qualitative variable, caste is qualitative variable. On the other hand, salary is quantitative and education is also quantitative. So which correlation coefficient we are going to use, that again depends on the nature of the data or structure of the data. So whether you have nominal variable, ordinal variable, interval variable, or ratio scale variable. So first, correlation analysis is useful to find the direction of the association. So whether we have negative or positive association. If you have negative association, that means value of one variable declines as the value of another variable increases. Value of one variable declines as the value of another variable increases. If we have positive association or positive correlation, we can say value of one variable increases as the value of another variable increases. Right? So price and quantity demanded are negatively associated because value of price increases, quantity demanded decreases. So here you can take the example of price and quantity demanded. If price increases, quantity demanded decreases. So they have negative association. On the other hand, here we can take the example of income and consumption expenditure. So higher the income, higher the consumption expenditure, lower the income, lower the consumption expenditure. The direction of the relationship can be observed with the help of scatter plot. So in scatter plot, on horizontal axis, we have one variable, suppose it is X, and on vertical axis, we have another variable. And then we plot the data points. That is the idea of scatter plot. So whether these two variables, the association between two variables show any particular pattern. So direction can be visualized with the help of scatter plot. But strength of the association cannot be found with the help of scatter plot, and therefore we need correlation coefficient. Right? With the scatter plot, we might identify that yes, price and quantity demanded are inversely related, are negatively related. But whether we have strong association between price and quantity demanded, we have moderate association, or we have weak association. So price and quantity demanded are strongly negatively related, moderately negatively related, or weakly negatively related. That we cannot identify with the help of scatter plot, and we need correlation coefficient to find the strength. Now see this diagram. On vertical axis we have X variable, and on horizontal axis we have X variable, and on vertical axis we have variable Y. So this shows the perfect positive correlation. All data points are on the straight line. Now here we are analyzing the linear relationship. So if you remember the formula, it is y is equal to mx plus c. So y and x are linearly related and m is the slope. Right? Y is equal to mx plus c. C is intercept and m is the slope. We have perfect negative correlation. All data points are on negatively sloped line, trend line. This is our trend line. We have strong positive correlation. You can see that all data points are not on the line, right? Some of them are on line or some of them are on just above the line or below the line, right? But they are not very far from the trend line. Similarly, we have strong negative correlation. Then we have weak positive correlation. If you compare this strong positive, weak positive, the data points are far from the line, right? And therefore we have weak positive association between x and y. Similarly, we have weak negative association between x and y. And here we don't have any particular pattern, and therefore there is no correlation, or there is no association between x and y. Now, how to interpret correlation coefficient? If R is -1, perfect negative correlation. If it is between -1 and -0.5, strong negative correlation. If it is -0.5, moderate negative correlation. If it is between -0.5 and 0, weak negative correlation. If R is 0, there is no association. Both variables are independent of each other. Between 0 and 0.5, weak positive correlation. R.5, moderate positive correlation. Between 0.5 and 1, positive, strong positive correlation. R+1, perfect positive correlation. So basically, the correlation coefficient ranges from -1 to +1. The value of the correlation coefficient ranges from -1 to +1. Are correlation and causation same? If you find correlation between x and y, suppose they are associated, can you find or can you explain the causal relationship between these two variables? And the answer is no. Correlation does not imply causation. Significant correlation between two variables does not imply causation. For example, suppose we find the significant positive correlation between IQ and level of income. We have these two variables, IQ and level of income, right? Now, this significant association fails to say whether higher IQ causes more income or more income causes higher IQ. We are just saying that these two are associated with each other. And with the help of correlation analysis, we cannot establish the cause and effect relationship between IQ and level of income. So correlation and causation are different. Now, how to formulate null and alternative hypothesis? What is null hypothesis in this case? The null hypothesis says that there is no correlation between two variables, or two variables are independent of each other, or population correlation coefficient is 0. So population correlation coefficient is denoted by rho, RHO, and sample correlation coefficient is denoted by R. Right? As I said earlier, that we always frame null and alternative hypothesis for population parameters and not for sample statistics. Alternative hypothesis, there is significant correlation between two variables, or two variables are not independent of each other. Sorry, here two variables are independent of each other and not independent of each other. Sorry. Let me check it once again. There is no correlation between two variables. Two variables are independent of each other. Okay. Population correlation coefficient is 0. There is a significant correlation between two variables. So two variables are not independent and population correlation coefficient is not equal to 0. So rho is not equal to 0. Now let's understand various types of correlation coefficient. See this table. As I said, the selection of the correlation coefficient is very important because it depends on the nature of the data, whether you have qualitative data or quantitative data. So first is Karl-Pearson correlation coefficient. Right? If both variable are ratio and normally distributed, so we need normal distribution. Then we use Karl-Pearson's correlation coefficient to find the association between two variables. Right? If both variables are either ratio or ordinal. So if they are ratio, they are quantitative but not normal, non-normal data. Or ordinal data, we use Spearman's rank correlation. So Spearman's rank correlation coefficient is a non-parametric test. Non-parametric test. I think you have the sessions on non-parametric test tomorrow. So I'm not going to focus on Spearman's rank correlation coefficient. Karl-Pearson is a parametric test, because you need the quantitative data and your quantitative variables must be normally distributed. right? Third, if you have ordinal data with many tied ranks, in Spearman's rank correlation analysis, we give ranks. But suppose you have many tied ranks, then instead of using Spearman's rank correlation, use Kendall's tau. So Kendall's tau is also a non-parametric test. You don't need to check the normality assumption to perform Kendall's tau. Right? Then we have point biserial correlation coefficient. One variable is ratio scale, that means quantitative. And another variable is dichotomous. That means you have nominal variable with only two categories. Then we perform point biserial correlation analysis. And if both variables are dichotomous, we use phi correlation coefficient. So these are some of the correlation coefficients which are widely used in social sciences. Carl Pearson, Spearman's rank correlation analysis, Kendall's tau, point biserial, and phi correlation. Okay, let's understand the Pearson's correlation coefficient. This correlation coefficient is also known as product moment correlation coefficient. It is useful when two variables are linearly associated with each other. So Pearson's correlation coefficient only examines the linear association, and it is not useful when you have non-linear association. So as I said, the equation is y is equal to mx plus c. This equation shows that x and y are linearly associated with each other. And this linear association can be positive, can be negative. If the two variables are normally distributed and ratio scale, then Carl Pearson's correlation coefficient is used. In these examples, suppose we are interested to find the association between income and consumption expenditure. So income is our first variable, consumption expenditure is our second variable. Both are quantitative and both must be normally distributed. Second, examine the association between stress level and productivity of employees. So stress level, quantitative data, productivity, quantitative data, both must be normally distributed. Third, to examine the association between air pollution level and cancer cases. So air pollution level is our first variable, quantitative, cancer cases again quantitative data. Fourth, to examine the association between hours of reading and result. So hours of reading is our quantitative data, result is again quantitative data. Then we have Spearman's rank correlation coefficient. I'm just giving you the idea so that you can easily differentiate between Carl Pearson's correlation coefficient and Spearman's rank correlation coefficient. Rank correlation is developed by Spearman, known as Spearman's rank correlation. It is used to determine the association between two ranked data or non-normal ratio scale data. It is a non-parametric measure. That means that the assumption of the normality is not required to perform this test. Right? With multiple tied ranks, we use Kendall's tau. So see these examples. To examine whether students getting higher score in mathematics are also doing better in English. So you first give ranks according to their score in mathematics, then give ranks according to their score in English, and then compare these two ranks. So students who are scoring higher in mathematics are also scoring higher in English. Second, to examine the association in rankings given by two judges. Suppose we have one event, you have one event in your college, you have invited two judges, and let's find whether the rankings given by two judges are associated with each other or not. Third, examine the association between investment and unemployment. Now you see, investment and unemployment both are quantitative data, but if they are not normally distributed, you need to use Spearman's rank correlation instead of Carl Pearson's correlation coefficient. Okay, so let me share my SPSS screen. Any doubt in correlation analysis in theory? Anyone? You can write in the chat box, or you can unmute yourself. Okay, so let me share my SPSS screen. Now we want to find the association between internal marks and external marks. Right? Let me open the original file. I'm not saving this. Yes. So let's find the association between external marks and reading hours. See our variable view, HRS variable, reading hours per day. So do we have any association between reading hours and result of the students? So first we need to perform, or let's try to visualize the association or the relationship. So let's see the scatter plot. So go to graphs, legacy dialogues, and scatter plot. Graphs, legacy dialogues, and scatter plot. Click on scatter plot. You have various options. So by default, simple scatter is selected. So just click on define. On y-axis, you can select external marks, and on x-axis, the reading hours. You can interchange this. There is no problem in order. Click on titles. So I'm giving the title figure or chart 1. External cross reading hours scatter plot. Click on continue and simply click on OK. See this chart. Double click on it. Let's fit the trend line. So here you have this option, add, this add a fit line at total. So click on it. Simply close this. So now we have this trend line, but you can see the trend line is slightly negatively sloped. But from this chart, we are not able to find the strength of the association, whether we have weak positive, weak negative association, or there is no association. And therefore, we need to perform correlate, or we need to calculate correlation coefficient, right? So go to analyze, correlate, bivariate. Why we are using bivariate? Because we are interested to know the association between two variables, that is external marks and reading hours. So click on bivariate, select our two variables, external marks and reading hours, move them to the variables box. See, by default, Pearson is selected in the correlation coefficients. So here you have three options: Pearson, Kendall-Staudt, and Spearman. So Pearson is selected. No need to change. Simply click on OK. And now we have this correlation matrix. Right? Now see Pearson correlation coefficient. It is minus 0.122. Now, before you interpret this, you need to check whether this correlation coefficient is statistically significant or not. Right? So the associated SIG value is 0.355. Now this associated SIG value is higher than 0.05. Therefore, we fail to reject H0. Now what is H0 in this case? There is no association between result and reading hours. We fail to reject this, and therefore we cannot find, or we cannot conclude that these two are associated with each other. Right? Okay, let's open the data file again. Let's see whether hours and total marks are associated with each other or not. So what is null hypothesis in this case? H0. No correlation between total marks and reading hours. Right? And what is H1? Alternative hypothesis: significant association between total marks and reading hours. Right? Let's see the scatter plot first. So instead of external marks, now I'm selecting total. And in titles, instead of external, let me write total. Continue. Okay. So from chart, we are unable to find the direction also. Let's try to fit the line. Go to bivariate correlation. Instead of external marks, select total and click on OK. So again, the significant value, the p-value is statistically insignificant. It is higher than 0.05, and therefore the correlation is not statistically significant. So there is no need to conclude, or there is no need to interpret the correlation coefficient. Right? So normally we see the mistakes here without checking the statistical significance. People directly interpret the correlation coefficient. It is completely wrong. You first need to check whether your correlation coefficient is statistically significant or not. And if it is statistically significant, then see the value of the correlation coefficient and then try to interpret it. Now let's find the association between internal marks and external marks, or internal marks and total, whether these two are associated with each other or not. So select total and internal marks in the variables box and click on OK. So first try to plot them, internal marks and total. So total cross internal scatter plot. Click on continue, click on OK. See this chart. Double click on it, select this. So now you can see positively sloped line. So from this chart, you can visualize the association, that yes, we might have positive association between total marks and internal marks. But whether this positive association is strong, moderate, weak, that we don't know, or we cannot identify with the help of scatter plot. So let's perform correlation. So select total and internal marks, click on OK and see result. Now SIG value here is less than 0.05. Since it is less than 0.05, we reject H0. If we reject H0, what we are going to conclude? Now you need to interpret the Pearson correlation coefficient. See, Pearson correlation coefficient R is 0.457. So we can say we have moderate positive association between total marks and internal marks. Right? Any doubts? Anyone? Okay, so you try to perform Pearson's correlation coefficient on internal marks and external marks. First, plot them on chart. So you can use graphs command and then find the Pearson's correlation coefficient. So write the correlation coefficient value and p value in the chat box. Okay, let me see the answer. P-value, Pearson's R is 0.072. P-value is 0.582. Okay, these two answers are different. Rahul sir, your answer is Pearson correlation is 0.65 and SIG value is 0.621. Okay, so in both cases, p-value is higher than 0.05. And therefore, we fail to reject the null hypothesis. So there is no need to perform, there is no need to interpret p-value, the Pearson's correlation coefficient. Right? Ranjit Thakur's answer is R 0.072, but p-value is higher than 0.05. So there is no need to interpret R. And in Rahul sir's case also, there is no need to interpret the value of R. Yes. Any doubts in theory, in practical, related to correlation analysis? No, sir. Okay. So let me give you the basic idea of regression analysis, and then I'll stop. Now, in correlation analysis, we don't identify that which group, which variable is dependent and which variable is independent. Right? We are just finding the association. But in regression analysis, we want to know the effect of one variable on another variable. Right? In regression analysis, sorry. So the simple linear regression model is also known as two variable regression or bivariate regression. Here we have two variables, right? Again, we are starting with two variables, X and Y. So, simple linear regression model examines the relationship between two variables. One is dependent variable, which is known as explained variable, target variable, regressant. Another variable is known as independent variable or explanatory variable, control variable, or regressor. So we want to know the effect of this independent variable on dependent variable. And therefore, we need to identify that which variable is dependent and which variable is independent. We need to tell the software, whether it is SPSS or Excel or RStudio, right? So how to identify dependent and independent variable? That depends on the subject domain. So for example, in economics, I know that quantity demanded depends on price. So quantity demanded is my dependent variable and price will become my independent variable. Consumption expenditure depends on income. So consumption expenditure will become my dependent variable and income will depend my independent variable. So regression is a statistical method to analyze the relationship between two or more than two variables. It basically examines the functional relationship. So this relationship explains the magnitude of change in one variable that is associated with the change in another variable. We must keep this in mind that regression does not explain the cause-effect relationship. Again, so correlation and regression are completely different from causal relationship or cause and effect relationship. Now, what is the difference between correlation and regression? In correlation, we are interested to know the relationship between two variables. There is no specification between dependent variable and independent variable. Variables can be interchanged. The association between x and y remains the same if you change the order. Right? So between x and y or y and x, the correlation coefficient remains same. Correlation coefficient shows the degree of association between two variables. It can't be used for prediction. We cannot predict the value of one variable with the help of other variables. Right? On the other hand, regression measures the effect of one variable or variables on other variable. Therefore, specification of dependent variable and independent variable plays an important role. So here you cannot interchange the variable. Dependent variable cannot become independent variable and independent variable cannot become dependent variable. Otherwise, the result will change. Regression coefficient shows the change in one variable due to other variables of the model. Therefore, it is used for prediction. So one of the uses of regression analysis is to predict the value of dependent variable for given values of independent variable. What is the use? To predict value of dependent variable for given values of independent variable. Right? So see simple linear regression model. I'm not going to focus on multiple linear regression model. Here we have two variables. Again, we are examining the linear association. Therefore, the name is simple linear regression model. SLRM is simple linear regression model. Right? Now see model specification. Suppose y depends on x. So yi is equal to alpha plus beta xi. Alpha and beta are parameters. Alpha is intercept and beta is the slope. What is the interpretation of slope? Slope is change in y for a unit change in x. So see this diagram. Alpha is intercept, beta is slope. Right? Now here this equation exhibits the exact relation between y and x. It is not true. Factors other than x can also affect y, but this equation says that all variation in y can be explained with the help of x. So to make this model adequate, we add error term. After adding the error term, we have this equation. Yi is equal to alpha plus beta xi plus mu I. Equation 2 is known as stochastic relation. Mu I is our stochastic error term or disturbance term. So error term captures the effects of other independent variables which are not included in the model, but they can influence yi. And now we minimize this error term to estimate the value of alpha and beta. So let's understand in SPSS. So you have the SLRM file, SLRM SPSS file. Let me open it. So this file has consumption expenditure and income. So we want to know, or we are interested to know, the effect of income on expenditure, right? So what is our equation? Consumption expenditure CE is equal to alpha plus beta income plus error term. Because there are other factors which can affect consumption expenditure. Gender affects consumption expenditure, culture, region, religion, savings. But we are not including them in our model, and therefore we are including error term. Now we minimize this using OLS method. So estimated regression line is consumption expenditure is equal to alpha hat plus beta hat, alpha hat plus beta hat. So these alpha hat and beta hat are estimated values of alpha. Right? Now you can predict the value of consumption expenditure. You can predict the value of consumption expenditure for given values of income. So let's see. Go to analyze again. In analyze, we have the option of regression, and in regression, we have the option of linear. So in regression also, we have various methods: linear regression, non-linear regression, logistic regression, logit and probit model. So we are interested in linear regression, so select linear. See, here you need to define the dependent and independent variable. So we are telling the software that this is our dependent variable and this is our independent variable. So what is my dependent variable? It is consumption expenditure, because consumption expenditure depends on income, and income is my independent variable. So move it to the independent box. Right? Go to statistics. Now here you have various options to check the assumptions. So for example, collinearity diagnostics, you have Durbin-Watson test. So whether you have the problem of autocorrelation or multicollinearity or heteroscedasticity, these are certain assumptions So I'm simply selecting descriptives. Continue. Okay. Now see the result. This is descriptive statistics. Mean consumption expenditure and mean income. This is Pearson's correlation coefficient. Yes, so we have these three tables. So let's understand this table first. See, both values are statistically significant, constant and income both. Because the value of p value is less than 0.05. So I can write the equation like this: CE, that is consumption expenditure, is equal to consumption expenditure is equal to, what is intercept? It is 26.60 plus 0.487 income. This is the regression equation. How to interpret this 0.487? If income increases by $100, the consumption expenditure will increase by $48.7. If income increases by $100, the consumption expenditure will increase by $48.7. Right? This is the regression equation. Now see ANOVA table. F ratio is statistically significant. Now ANOVA table is used to check the statistical significance of the entire model. So whether we have specified the model correctly or not. So that means model specification is right. Is correct or right. And then we need to check R square. Now what is R square? R square explains the variation in independent variable, in dependent variable that can be explained by independent variable. So here R square is 0.879. We can say 87.9% variation in consumption expenditure can be explained by income. Right, 87.9% of consumption expenditure, variation in consumption expenditure can be explained by income. So we have these three tables. So this is the idea of regression analysis. Yeah, so that's it from my side. If you have any questions, you can write in the chat box. I would like to thank Bharat College, Savita ma'am, Neetu ma'am, once again for providing me this opportunity to interact with these students, and I hope these sessions. Thank you. Thank you.
Sir, it was Neetu ma'am here. Sir, it was really nice. I was there continuously since yesterday. The way you have interpreted and the hands-on that what we talk about, the way the session went, it really was really useful for the learners to start up with. I think we would be there continuously admiring you and be there as your students continuously whenever we make our research papers to take guidance from you on statistical analysis. It was very good. And I don't think anywhere anything was Like it was a complete package of learning on parametric test. I think it went very well, very nicely.
Thank
And the way the responses were coming, it shows that everything was going very well. So thank you so much for accepting our invitation. And the 2 days journey really went very well. Thank you so much, sir.
you.
Sandesh, sir, back to you. Sandesh,
Yes,
sir.
sir. Sir, it was a very good journey with you. We
Thank you,
learned
thank
many
you so
things
much,
and we
ma'am.
were able to do simultaneously. I
Thank you.
thought hands-on training online would be difficult, but I was wrong. I was proved wrong. It was really helpful for all of us.
Thank you, thank you.
Thank you, sir. I think Sandesh sir is not there.
Yes, miss.
Rushali ma'am.
Miss, I am there.
Okay. Okay.
he's
Over to you,
there.
Sandesh sir. Yes.
So if anybody has any question, please ask. Anyone wants to ask anything to sir? Miss, can we wind up?
Yes. Yes. Sir.
Good evening, one and all. On behalf of Bharat College of Arts and Commerce, it's my privilege to propose a vote of thanks on 7th day of this 10 days national level training and capacity building program on research methodology. First of all, I would like to thanks to our management and ICSSR for supporting to organize this 10 days workshop. A special thanks to today's resource person, Dr. Atman Shah, for sharing very useful knowledge about the statistical tools and concept that we can use in our data analysis. Thank you very much, sir. We are really enlightened with your presence and knowledge. Next, I would like to express my sincere thanks to our in-charge principal, ma'am, Dr. Nitu Kapoor, for her continuous motivation. I'm also very grateful to IQSC coordinator and convener of this program, Dr. Savita Punjabi and entire team for organizing this program. Last but not least, I would like to thank all the participants for attending and their patient listening. Thank you very much. Thank you one and all.
Thank you, sir. Thank you so much. Savita, ma'am, I'll share the PPT with you on the
Yes,
given
yes,
email
sir.
ID. You can share with the participants.
Yes. Yes. Sir. Sure. Sure.
Thank you.
Thank you, sir.
Thank you,
Hope
ma'am.
we connect once again for some other program or
Definitely,
for
definitely.
some other thing. Thank you so much. It was really perfect session, I should say.
Thank you so much. Thank you.
Very patiently handled, sir. Very patiently. The way you went now, that was really awesome. So
Thank
it was
you,
very
thank you.
nice. Thank you so much.
Participants, please fill the feedback form for both the sessions. Rushali ma'am, you can end up the meeting.
Yes,